All right, moving on, we are going to talk about the organization of the elements into the periodic table. This should be starting off with a little review from the YouTube video you just watched on Dmitry Mendeleev, and that's where we're going to actually start. A little bit about Dmitry Mendeleev, that was probably mentioned already in that video. He is a Russian uh, scientist here, and then in 1869. And what he did was he looked for patterns in elements' behaviors, so how they reacted to different situations, which ones did the same thing, which ones had very similar properties, those kind of things. So he's going to look at them. Some of the patterns that he has figured out in some things that you should know. I am going to be using the chemical symbols for all of these just to get you used to reading things by the letters instead of the actual names here. But F is fluorine and Cl is chlorine. He noticed that fluorine and chlorine are both irritating gases. You do not want to sit here and breathe in these things. They will burn your nasal cavity. They will uh, just make an unpleasant experience for you. Chlorine gas is also called mustard gas. They used to use it in the World War I in the trenches. Now it is considered a pretty bad move if you're using that in war. It's frowned upon, chemical warfare and stuff. Cu is copper and Ag is gold. Or I'm sorry, Ag is silver. Au is gold, Ag is silver. Copper and silver both tarnish when they're exposed to air. You probably know that if you have fancy silver in your house, that it probably gets polished, or mom, dad complain that it never gets polished and it should be polished. But you probably noticed copper turns kind of a greenish color when it tarnishes and stuff as well. He also noticed lithium, Li, sodium, Na, and potassium, K, react violently with water. So here we have, where's my mouse? There it is. Lithium reacting with water, and you can see how it's sparking off and giving a big reaction. Over here we have potassium reacting with water, and you can see how it's giving off a much bigger reaction to it. But they all are going to, when exposed to water, they are going to react violently. He decided that we should organize our elements based on atomic mass. He did this because we did not know about protons at the time. So we couldn't measure those positive charges and those negative charges of protons and electrons. So we don't know how many protons there are in these things. So we can't do it by atomic number, which we do today. So Mendeleev decided to do it by atomic mass. After he put them in kind of order based on their properties, he noticed that they increased in atomic mass. The atomic mass, again, is an average of all the isotopes of that element. So it is an average, and that's why it's going to be kind of an ugly-looking decimal number as opposed to the atomic number, where you can't have like a fraction of a proton in your element. When he did do this, he noticed if it had to fit in with the patterns that he had, then there were gaps where atomic mass would work. So it didn't line up entirely correctly. So in order to compensate for these little bumps in his table, he predicted that there were elements that existed that will eventually be found and put into them. Scandium, gallium, and germanium, I believe, are those ones, were the three that he predicted. And he also predicted that this is where they would be atomic mass-wise, and this is where they would be property-wise. And within 16 years, they were found, and he was correct. His predictions were shown to be accurate in that he knew the atomic masses of these elements and their properties before he even knew they existed, just based off of his organization of that periodic table, which is a pretty powerful thing. Today's table is a little different. In 1913, Henry Moseley was able to measure charges. So now we have the identification of protons and electrons, and we can take Mendeleev's table and we can rearrange it slightly by atomic number as opposed to atomic mass. That way things actually go up 1, 2, 3, 4, 5 instead of, well, hydrogen has the atomic mass of 1 or 2, really, if you have a neutron in there. Helium will have like 4, 2 protons, 2 neutrons, and so on. So I kind of skipped a number over there. Now with atomic number, we can go by just 1, 2, 3 in a chronological order there. But that was because of Henry Moseley. So now we have our elements are going to be shown in periods or rows based on Moseley's discovery of charges. Again, he's going to rearrange them by atomic number now, and we are now going to be identifying our elements based on atomic number as opposed to Mendeleev basing them on atomic mass. So here is one square out of our table with some basic information on it. This is neon. Ne, neon is a noble gas. Neon's atomic number up here is a nice whole number of 10, meaning neon has 10 protons. Because neon has 10 protons, or 10 positive charges, it needs to cancel out those charges with negative charges, and therefore neon also is going to have 10 electrons. Down here we have our atomic mass number. I know this because, again, it is that decimal number. It's not always the greatest, and it is an average of all the different isotopes of neon that are found. So neon can exist with 10 neutrons, 11 neutrons, 12 neutrons, 9 neutrons, right? So we're going to average it all up, and we're going to get this number here as our atomic mass. The next slide is going to talk about atomic symbols, and our symbol for neon is Ne. So our symbols are mostly English abbreviations. You can probably assume where Ne comes from neon. Some of them are not, especially the ones that were early found in Mendeleev's time. They are Latin because that was the language of Latin. So I do want you to pay attention to the ones with non-English symbols, especially the common ones that we use, such as iron, which is Fe. It stands for ferrous. Lead would be Pb. It stands for plumba, or plumbum, also where the word plumber comes from, because plumbers would use lead piping and things until we realized that, well, lead wasn't the best choice. Potassium is K, tungsten is W. There is a handful of them out there. Sodium's another good one. Sodium is Na. But be familiar with some of the weird ones as you look over your periodic table.